Assalamualaikum and very good day to Dr. Mat Zarafi bin Ahmad. My name is Siti Hajara binti Abdul Aziz Krish, and today we will present about the assignment of electric drive, and we are from group 2 in section 1. This is the member for this group. First, Roshada binti Ismail. Second is me, Siti Hajara binti Abdul Aziz Krish. Third is Muhammad Haris Akmal bin Muhammad Hairani. Fourth, Nabil Fikri bin Rosli, and the last, Wong Cheng Kang. So, our content data in this assignment consists of introduction, includes project background, problem definition, methodology, result and discussion, and for the last, conclusion and recommendation.
Hello and Assalamualaikum. My name is Nabil Fikri from group 2. So, I will present the introduction. So, first of all, electric drive is the system which is used for controlling the motion of an electrical machine. An electrical drive is defined as a form of machine equipment designed to convert electrical energy into mechanical energy. So, in the other words, the drive which uses the electric motor is called electric drive. The electric drive uses any of the prime mover like diesel or a petrol engine, gas or steam turbines, steam engines, hydraulic motors, and electrical motors as a primary source of energy. This prime mover supplies the mechanical energy to the drive for motion control. So, in this assignment, we need to develop a simulation of variable speed DC motor by using MATLAB Simulink software, and the system must consist of DC motor, proportional integral derivative or PID as a speed controller, and a microcontroller algorithm. For application of DC motor in this assignment, we choose a DC vacuum, which is the DC motor work to become a air suction for cleaning.
Hello and Assalamualaikum. My name is Siti Hajara binti Abdul Aziz Krish. I will continue the presentation about the problem definition. So for problem definition and objective, first, problem statement. Variable speed DC motor need a specific parameter to be applied in some application to work properly. Comparing between an AC vacuum and DC vacuum, an AC vacuum consumes much current and power. In the other side, the most frequently discussed issue in speed controllers is their efficiency and reliability. In order to save energy, efficiency is essential. The speed controller's efficiency of DC motor is determined by its control system method. The speed controller is typically used to control an analog system. In this technology era, manual controller is really not practical. For this assignment, we will discuss the usage of proportional integral derivative, PID, and microcontroller to be applied to the motor. Next is for the objective. First, to develop a simulation-based variable speed DC motor drive by using MATLAB Simulink software. Next, to identify the output of the developed simulation in MATLAB Simulink software. And the last, to study the working principle of the variable speed DC motor based on developed simulation.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris Akmal bin Muhammad Hairani. Matric number CE190162, and I'm from group 2, and I will present about methodology for our group. The first one is the block diagram that we use for our circuit. It starts from the reference speed 1600, and then we use a PID block, signal generator, which is a PWM subsystem with input 40 kHz for frequency, MOSFET for switching, buck converter, and self-excited DC motor. And lastly, we will get our desired speed, and then we will continue. If we don't get our desired speed, and then it will repeat again through the PID and through the other system. Next, I will explain about our flowchart. Basically, this flowchart is already applied for our application, which is a DC vacuum. So you can see, from the start, the DC vacuum will be power on. 240 volt supply, that we use will be supplied to the circuit. Then it will go through MOSFET for switching. After switching, the 240 volt will go through buck converter to lower down the voltage, which is 144 volt. And 144 volt, this is our rated voltage for our application. Next, V out, which is 144 volt, will power up the armature winding in the DC motor. Next, the user will set the speed of the vacuum using the regulator from 1 to 3. Then, from the speed that has been set, DC motor will start to rotate. After rotate, the speed will be adjusted by the value of Kp, Ki and Kd in the PID controller to eliminate the error and produce the same speed from the desired speed. So, lastly, the output speed will be similar with the reference speed. If it is different, and we will return to adjust the PID to get the same speed. DC motor rotate with the output speed. And next, for our circuit, we use 3 combinations of system. The first one is buck converter block. Buck converter block will lower down the voltage, as I stated earlier, from 240 volt to 144 volt. Next, we use PID controller block, or also known as PWM subsystem, to generate the signal and to adjust the output speed using PID. And lastly, separately, DC motor block. This is a block for motor, and we will see it more clear in our simulation. This is our circuit for the simulation. With the reference speed 1600. Next, our input torque is 20. Input voltage 240 volt. Field voltage 300 volt. Just we follow the preset of the DC motor. And lastly, our PID setting. And then we will run it. In the simulation, I only simulated for 3 seconds because I think it's long enough for the system to generate the waveform in a stable way. You can see it after this. In less than 3 seconds, the system is already stable, and it will continuously until the vacuum is stopped. I'm sorry for the long time, and this is our signal. So you can see, in less than 3 seconds, our waveform already achieved a stable state, and it will continuously stable until the vacuum is stopped. That's all from me. And then I will pass my presentation to my friend Rashada. Thank you.
Okay, thank you, Haris. My name is Roshada binti Ismail. My metric number is CEY90182. Okay, so in our part, I will explain more about result and discussion. Okay, this is our DC motor parameter. DC motor parameter, which is we choose a value for our design. So we choose input voltage 240 volt. For the field voltage, we choose 300 volt, and for the RPM, we choose 1750 RPM. For the horsepower, we choose 5 horsepower. For the desired speed, we choose 1600 milli per second, and for the torque, we choose 20 Nm. Okay, as you can see, this is our initial speed graph. So the first, we don't change any value at PID controller. So this is the original one. Okay, so the result, we got 1634, which is we got the overshoot from our desired speed. Okay, so we decided to troubleshoot our graph. Then we decide to change the value at a PID controller. Okay, so this is our second troubleshoot. We decided to change the value of integral I from 1 to 0.001, and we got the result 1599 speed. Okay, so as you can see, the result we got is below than 1600. So we decided again to do troubleshoot at PID controller. Okay, this is our final graph. We decide to change the value at proportional from 1 to 10. We keep the value of integral 0.001, and we also change the value derivative d from 0 to 0.1. Okay, so finally we got the steady state of 1600 speed, which is same as our desired speed value. So we know that PID controller is to control the output to a desired speed via closed loop control. Okay, next, for input current graph, this is our input current graph, and we got the value 35.52 ampere. Okay, last, output voltage graph. This is our output voltage graph, and we got the output voltage 144 volt. Okay, which is suitable with our application DC vacuum. Okay, output voltage, since we use a buck converter, so we know that function of buck converter is to step down our voltage. So in our application, the voltage is dropped from 240 to 244 volt. So I think that's all from us. Thank you, Doctor.
Hi, Dr. Zarafi. My name is Mong Jin Kang. Can call me CK. My metric number is AE180110. I'm from Group 2. Today, I will represent my group to do the presentation for group assignment. And I will present the part, conclusion, and recommendation. And now I will do the presentation for conclusion part first. The conclusion part I separate into two parts. The first part is theory. We done study on the variable speed DC motor drive with buck converter, which is applied into DC vacuum. We also learn well about the system and subsystem of the drive that we use and the working principle of the system. The system of the drive that we use is buck converter, DC separately excited motor, and PID controller. And the subsystem drive that we use is PWM subsystem, and we can get the result of the output value of the system. By using the output value we get from the system, we can know that very well about the characteristic of speed time graph of speed. After we know about the characteristic of the graph, we get to learn the function of the PID controller, which help us to control the output to a desired speed via closed loop control. And now I will present the second part is interpersonality. In this assignment, we work in a team and we gain more confidence on how to solve the problem. And the soft skill is very useful for us in the future, which can help us in our industrial training or real life working situation. And this assignment is very effective, which can train us to prepare ourselves for future working application. And now I will do the recommendation for this group assignment. With intricate motion and high accuracy requirements, the usage of electric drive is expanding in various systems, such as electric vehicles, renewable energy systems, and robotics. Furthermore, the evolution of and use of multi-phase electric machine and power converters necessitates accurate, rapid, and efficient speed and position management, which is impossible to achieve with traditional control system. To improve the functioning of electric drive, smart control systems are emerging that include artificial intelligence to sensorless and wireless principle and data analysis for adaptive modeling. As a result, research in this subject will continue expanding. That's all my presentation for conclusion and recommendation. Thank you.